So now that we have a good copy of the unit circle in mind, we're going to begin looking at how to use the information on that to answer various different questions. So here are a few terms and rules we'll need to keep in mind for some of the questions dealing with the unit circle. The first and the easiest one is the measure of an angle. Well, whenever you see the measure of an angle, that's just talking about how much rotation has there been from the beginning position, which usually starts from the right-hand side, and then rotating around to the ending position, which is sometimes called the terminal side. Many questions will mention the terminal side, or they'll give you a point on the terminal side. That just means it's a point where your angle of rotation stops. Positive angles are measured counterclockwise, so you start from the right-hand side of the unit circle and you measure around counterclockwise, so going around up and to the left if it's a positive angle. If it's a negative angle, then you use that measurement to go clockwise, as in down and around to the left. Coterminal angles are another very important concept for this class. They're angles that have the same terminal side. So what I mean is if you have the end of your rotation, if you have a line that's pointing straight up, there are actually an infinite number of ways of referring to that location from the unit circle. The most common one is to say that it's 90 degrees, but if you spun all the way around again, one full rotation around, you would end up pointing up again, but that would be a different angle. That would be 450 degrees. And you could just keep spinning around, spinning around, spinning around, and as long as you're still pointing up, that's another way of writing the angle. So to elaborate on coterminal angles, these are angles that differ by an integer multiple of 360. Now, what I mean by that is if I took a random angle, like let's say 90 degrees, well, if I added 1 times 360, 1 is an integer, so if you multiply that by 360, you would get 450 degrees. So 450 and 90 are coterminal angles. Well, I could do it again. What if I added 2 times 360? 2 is another integer. If I multiplied that by 360, that would be 720. So if I did 90 plus 2 times 360, like I said, this is 720, and 720 plus 90 is 810. So this is another coterminal angle. And if I keep repeating that process, if I do 3 times 360, 4 times 360, 5 times 360, if I keep adding them to the angle 90 degrees, then they're all angles that describe the exact same position, the ones that are pointing straight up in your unit circle. So that's what a coterminal angle is. Now, I should also mention that I was showing the positive values, but I could also do negative 1 times 360, negative 2 times 360, negative 3 times 360. So basically, if you keep adding or subtracting 360, those angles are the same, essentially, for most of our purposes. And then the same thing applies to the radian measurements. If I have a radian measurement like pi over 2, I can add 2 pi, or I can add 2 times 2 pi, or 3 times 2 pi, or 4 times 2 pi. And those will all be other ways of writing the exact same angle, so they're called coterminal. Now, in general for this class, we want our angles to be between 0 and 360. So if your angle is too big, then subtract 360, and then keep doing that over and over and over again, subtracting 360 at a time until you get a number that's between 0 and 360. If your number is too small, like if it's a negative number, you need it to be at least 0, so if it's negative, it's too small, then you will add 360, and then repeat that process over and over and over again until you get a number between 0 and 360. The same process can be done for radians. You want a number between 0 and 2 pi. So if it's bigger than 2 pi, subtract. If it's smaller than 0, like a negative number, then add 2 pi. And repeat until you get a number between 0 and 2 pi. So those are what coterminal angles are. Just keep adding or subtracting 360, or adding or subtracting 2 pi if you're in radian mode. Here's a quick example. They want 2 positive angles and 2 negative angles that are all coterminal with 70 degrees. So if I start with 70, I could add 360, or I could add 2 times 360. So this is 1 times 360, 2 times 360. I also could have done 3 times 360, 4 times 360, whatever I wanted. Either way, these should give me some positive answers here. So for my positive coterminal angles, I'm going to have 430 and 790. Those two angles are essentially the same as 70 degrees. And then I need to do the opposite direction. They want me to find two negative angles. So that means I'm going to need to subtract 360. And they want another one, so I'm going to subtract 360 again, or you can think of it as 2 times 360. Same thing. So for these two answers, I'll have negative 290 degrees. That's one negative coterminal angle. And for a second coterminal angle, I have negative 650 degrees. Now we're going to do the same thing for a radian measurement. So for radians, my angle is pi over 2. They want me to add 2 pi. And then I'm going to add 2 times 2 pi, which is 4 pi. Now don't forget that for these you do need to get a common denominator since I'm adding fractions. So you might want to think of 2 pi as 4 pi over 2. So 4 pi over 2 plus 1 pi over 2 is 5 pi over 2. Make sure you remember your rules for adding and subtracting fractions. And then 4 pi, think of that as 8 pi over 2. So if I add 1 pi over 2, 8 pi over 2 plus 1 pi over 2 is 9 pi over 2. And then if I want to do the same thing by subtracting, because I need two negative coterminal angles as well, so I'm going to add negative multiples of 2 pi. So pi over 2 minus 2 pi for one of them, and pi over 2 minus 2 times 2 pi for another one. So again, 1 pi over 2 minus 4 pi over 2, that would be negative 3 pi over 2 for common denominators. And if I'm doing 1 pi over 2 minus 8 pi over 2, this would be negative 7 pi over 2. So those are just a couple examples of coterminal angles for 70 degrees and pi over 2, but there are actually an infinite number of them, because I could have done pi over 2 plus 3 times 2 pi, pi over 2 plus 4 times 2 pi, pi over 2 plus 5 times 2 pi, etc. This is a diagram to help you with answering questions about when will the sine function be positive or negative, when will cosine be positive or negative, and when will tangent and cotangent be positive and negative. Well, I have a phrase written underneath as well that some students like to use to memorize this. And the ASTC, this is for representing the top right, top left, bottom left, and then bottom right sides of your quadrant. So the A stands for all. The S stands for sine. The T stands for tangent. And the C stands for cosine. So one way to help remember this is all students take calculus, because in the top right quadrant, all of the functions are positive. That's what the A is representing. All of them are positive here. In the top left, only sine is positive. So just the S for sine. In the bottom left, you'll see that only tangent is positive in the bottom left. The other two are negative. And in the bottom right, only cosine is positive in this quadrant. So this is just a way of remembering which functions are positive and negative where. But really, I feel like a lot of this is easier just by later on talking about the fact that sine is based on the y coordinate, cosine is based on the x coordinate, and tangent is y divided by x. So if x and y are both positive or both negative, it's positive. If one is positive and one's negative, then it flips negative the other way around. So whatever helps you to remember this information, whatever way you want to do it, that's fine. You will have a few questions asking you, is sine positive or negative in this section? So here's one type of example you'll encounter in the assignment. They have asked us to state whether sine, cosine, and tangent will be positive or negative, and the region they're specifying is here in the interval from 0 to 90 degrees. Well, what you want to remember about the unit circle is that 0 degrees is here on the right, and 90 degrees is up here on the top. So if they're saying from 0 to 90 degrees, they're talking about this first quadrant right in this section. So this is telling me quadrant 1, and then we need to state, is sine positive or negative there? And then is cosine positive or negative there? And is tangent positive or negative there? Well, according to the shortcut, the mnemonic device that I was giving you guys, in the top right quadrant, it's all students take calculus, so all of the functions are positive here. Sine, cosine, and tangent are all positive. Here's another example asking us to specify the positive or negative sections. So you'll probably want to look at your unit circle for reference on where these different angles are located. 100 degrees, for example, that's just past the 90-degree mark, which is pointing straight up. So this one must be up here in the second quadrant. And so the rule for this one was all students take calculus. So students is in the second quadrant, S standing for sine, so sine is positive there. 11 pi over 6, if you are looking at your unit circle, this one is really close to 2 pi. It's just underneath it, so it's down here in the fourth quadrant. And this was all students take calculus, so cosine is positive here. C was standing for cosine, but cotangent is negative in that section. And again, you can also see that by looking back at the diagram I had drawn for you guys. And then this last one, you need to identify where is 4 pi over 3 on the unit circle. Well, here's pi. 4 pi over 3 is down here in this third quadrant. So if you're doing anything in the third quadrant, all students take calculus, only tangent's positive down here, T for tangent. So since this is a different function, it must be negative in that section of 4 pi over 3. This part of the assignment will require the most work rather than just like looking at a reference or a chart to find the answer. So now they're going to give you an ordered pair somewhere, and you're going to use that x and y value to create a triangle. The x coordinate will be the base of the triangle. So I mean like it'll be the left and right horizontal part of your triangle. The y coordinate they give you will be the height, whether it goes up or down. The directions do matter, whether it's positive and negative values. Even though it doesn't really make sense to have a negative side for a triangle, the negatives will help you for getting the like sine of this number correct or the cosine of this number correct. Because the sine, cosine, and tangent, the trig parts, those do care about whether it went positive x to the right or negative x by going to the left. Same thing for the y's. If it went up, then that would be a positive y value. If it went down, it would be a negative y value. So do include the signs, and it'll make this part a little bit easier for you. And then you'll need to find the length of the hypotenuse using the Pythagorean theorem. So once you know two sides of the right triangle, you can find the third with a squared plus b squared equals c squared. From there, if they ask you to write all 6 trig functions, you should be able to fill them in based on the drawn triangle. So here's my example. I have the point -3, 4. So if I started from the origin and went left 3 units and then up 4 units, my x is -3, my y is +4, and then my diagonal for this right triangle, a squared plus b squared equals c squared would give me 5. This is one of those Pythagorean triples we looked at earlier. So without even doing the Pythagorean theorem, you can find that answer. So now I know the 3 sides of my triangle. And theta is always going to be here in the middle corner of your triangle. So if it had gone to the right, it would have been on the left-hand side of it. If it had been going down, keep that in mind. But it's always the one next to your origin from where you started drawing. Now that I have all 3 of these sides, I can just fill in the 6 trig functions. I just paused to set these up to save time in the video. So now I can just go ahead and start writing what is sine of theta. Well, the rule for sine is opposite over hypotenuse. So +4 over +5, that can't be reduced. So that's my answer there. And I might as well go ahead and do the reciprocal one, because I can just flip that fraction upside down to write 5/4 now. Next, I have cosine. From theta, that would be adjacent over hypotenuse. And like I said, negative values on triangles usually don't make sense, but I wanted to keep track of the fact that I was going left 3, which is a negative x coordinate. So now for the triangle, it does matter. It's adjacent over hypotenuse, so -3/5. So please keep the signs included if they had a positive x or y value on the coordinate they gave you. And then secant is just going to flip that fraction upside down. So now it's -5/3. For tangent, the rule is opposite over adjacent. So I have -4/3. And for cotangent, the reciprocal is -3/4. So use the ordered pair to create the base and the height of your triangle, keeping mind of the positive and negative values starting from your origin, and then find your last side using Pythagorean theorem. Everything else is just our SOHCAHTOA rules. So that's it for the notes, guys. Thanks.